That's why today I'll use LLAMA3 and GROQ. To be honest, I'm quite impressed with LLAMA3 because it can identify and extract tone. It's a very beautiful. And here we have Tim Cook and then apples.
Hey guys, it's Wilson back again. Few days ago, I shared a basic tutorial on how to chat with our knowledge graph. And if you still remember, we used a structure format which is a CSV files from Keiko. Today, let's delve more into the most interesting challenge, which is converting any unstructured text data into a knowledge graph. You'll find all the necessary code in the descriptions below, so feel free to use with your own data and your use case.
First, let's talk about what I mean with any text. So as we know that in this real world, text is ubiquitous. It comes from many sources. We have the TXT files, markdown files, PDFs, website, Wikipedia, and even YouTube. We can load a transcript. So the next question is how to load this text. And using LangChain, everything becomes easier. So for loading a text file, we have this text loader, and then PDF loader for a PDF, web-based loader for a website, and then Wikipedia from Wikipedia, and also a YouTube loader. And if you notice, all of the output in here, we have the same format, which is the documents. So this is the first goal, and once we have converted our text into these documents, we are good to go to continue to our next step. In this tutorial, I'm using Wikipedia loader. So a few days ago, Tim Cook, the CEO of Apple, came to Indonesia. It was an exciting news, and that's why I want to know deeper about him. Using the Wikipedia loader, you have several documents, and as you can see, of course, I don't want to use all of it because sometimes it's not relevant. For example, in here is a Canadian military, which I don't want it. So that's why I did a simple filtering, resulting this raw documents. As you can see in here, it's a very long text, and of course, our LLM model can process it in one run. And that's why I used recursive character text splitter to split it into several documents. The next step is MapReduce Summarization. Actually, it's optional. If you want to process all of your text, then just skip this process and go to the next step. However, I just want to take the most important part is documents, and that's why I'm using MapReduce Summarization. I experimented with LLAMA with Mr. Model, and it took a quite long time, around 8 until 10 minutes for each runs, and I ran for 3 times. So I already saved it, and this is the result. And as you can see in here, each iteration resulting slightly different results. And that's why I did a little bit editing and end up with these final results. You can explore more with other LLAMA model or Hugging Face API or OpenAI API, anything that you want, because as we know, each model will result a different kind of results. But in my opinion, this final result is good enough, and that's why I'm not trying with other models.
Coming from a data science background, we're talking about text processing or NLP. The tools that came onto my mind was Spacy or NLTK. So the first thing that I did was I searched about how to leverage this kind of libraries on creating a knowledge graph. And it turns out I found an incredible tutorial by LangChain. See, use spacy-llm. So I followed her tutorial, but instead of relying on OpenAI API, I tried an experiment with some open source model. So the first one is Mistral 7B Instruct model. Set up CUDA, download the model. It took quite a long time for me, around 20 minutes, but at the end, I always ends up with a kernel crash when loading the files. I moved the code and also faced the same problems. The reason is the Mistral model is quite big, around 14 GB, and as far as I know, spacy-llm is not supporting us to use a quantized model. So at the end, the only solution that I thought was on using a smaller model like using a 3 billion parameters models. Based on spacy documentation, there are several models that are supported, such as OpenLLaMA, cypher-llm, and also Dolly. I tried and it works. However, I'm not satisfied enough with the result.
No models could extract relations, and that's why I tried to seek for a solution until I find this GitHub issues in the explosions Git repository. The exact same problem until I realized that one of the developers said this.
So up to this point, I would say spacy-llm is a good choice if you have enough RAM, enough disk to load a bigger model, or if you're willing to pay for an OpenAI API so you can load it the model from the API.
So for now, I'm forgetting about using spacy-llm for this task but I try to gain insight as many as I can from their GitHub repo. So the first thing that I notice is about entities extractions. In here, they provide us a space to identify the labels that we want to get, the answers that we want to get. For example, here we have these ingredients and equipment. And this same strategy is also applied for the relation extractions. If we pay attention here, we can also specify the labels, its flips in and visits. And the last thing that I noticed from this repository is the use of the few-shot prompts. To not only give the instructions and guidance, they also provide an example for the LLM. For example, the original text is Laura bought a house in Boston with her husband Mark. And the first entry is person, GPE person, and the relationship is lives in. In my opinion, those three things are the reason why spacy-llm is better if we compare it to just the basic spacy, or if we pass directly all of our text to the LLM. So we give it guidance, instructions, an example, not letting our LLMs to think by their own imagination. And that's the way we will get a better results. During this exploration, LLAMA3 model came out. And that's why I thought, why not use this model to convert our text to the knowledge graph? And that's why today, I'll use LLAMA3 and GROQ. It's all free, very fast, even we use the 7B parameter models. So now, let's get started. Since we're going to access our LLAMA3 model using GROQ, so the first thing that we need to do is to import getGROQ from LangChain, and then also access the API key. And if you still don't have any API keys, so just simply go to console.groq.com and create an API key. It's totally free. Once we have done the setup, now I want to explain further about the process of converting our text to a knowledge graph. So if you still remember, there are three things that I want to replicate. The first one is to define the entities, the relations, and also the few-shot. Actually, I'm inspired with what Milena Zhirchinovska has done in her experiment in using schema.org in dividing entities and relationships. In my opinion, schema.org will be helpful because it provides us with very detailed explanations and descriptions about entities and relationships for most of all cases in this world. For example, you have drug data, then you can use the schema.org for drug, and product if you have a data set about e-commerce product, or maybe if you have a very specific data about music recording, you can also use this. But in this case, since we're talking about Tim Cook and Apple, and that's why I'll talk about person. So if you see here, there's lots of entities and relationships. For example, alumni of the word, birthday, and many more. So in the entity types, I have at least person, school, a word, company, product, and characteristic, and also relation types, alumni of, workforce, and many more. And then the next part that I want to explain is about the prompt itself. So the first thing that we want to define here is a system prompt. The key important part is in here. Head key must contain the text of the extracted entities with one of the types in the provided place in the user prompt. And then the head type is the type of the extracted head entity, the relation between the head and tails is the extracted entity and tail type. I've also defined the examples. So, Adam is a software engineer in Microsoft since 2009, and last year he got an award as the best talent. So the head is Adam, and the head type is person, which is from Microsoft, which is Microsoft as a company. And in here, Adam has award as the best talent, and many more. The next part is I define an output parser. Since I want the output is in a list of JSON, that's why I need a JSON output parser. And next is a human. In here, I define entity types, relation types, and example. And then we define the getGROQ model, which is LLAMA3 7D. So the next thing is, we want to process the clean summary text. If you still remember, we have already have it in here. So the process, we could run this line to open it and then split it by the dot. And also, using chain.run, we define here the entity types as the parameter, which is the entity types, relation types, examples, and the text is a sentence from here. So we could run this one. And this is the result. To be honest, I'm quite impressed with LLAMA3 because it can identify and extract the entities and relationships quite perfect. For example, here, Tim Cook works for Apple, and then iPod Nano is produced by Apple's, and Apple's is funded by Steve Wozniak. Macintosh is produced by Apple. So yeah, I'll say it's pretty good. But of course, LLM is not that perfect, right? Because in here we can select E. Actually, he is refers to Tim Cook, and then in here Cook, which is refers to Tim Cook. So I don't want to have a duplicate nodes and entities that have the same meaning, so I still need to do a little bit reprocessing here. Okay, so this is the final result after I did a little bit preprocessing. Now, the very last step is how to convert this to a Cypher query and then insert it to our new Neo4j database. So in here, the first thing that we need to do is to access this txt file with this cell, and here we can see the entities and relationships. Then go person numbers for apples, and go client and inventory, touching measures, and many more, which is perfect, I think. We want to insert the entities to our new Neo4j database, but we want to make sure there is no duplicates. That's why I'm using set and then also using here to get the unique entities. If you can see here, the result is like this. Steve Jobs as a person, and then Macintosh as a product, Richard's screens leader as a word, and many more. And then the next step is to insert these entities to our Neo4j database, which we can use as query. In here, we identify the ID, entities, and labels. For ID, we did a little bit preprocessing to replace a space and a hyphen and to make it lowercase. So we can run this, and that's the result. Right. So here we have the ID, which is Steve Jobs, and Steve Jobs is a person, and Macintosh, which is the product, and the ID is Macintosh. So it's good. And now let's define the relationships. To define relationships, we can simply use this, right? And then the head, and what is the relationships and to what, which is the tail. So here we define the head as the head of the entities and also the tail, and we could run this. If you see here, we have this. For example, Apple operates App Store, and Apple a career placement. Apple has Project Apple Maps. Project Titan has characteristic and self-briefing card technology, which is perfect. So the last thing to do is to connect to our Neo4j database. I'll go directly into connect it, but if you want to know how to set up Neo4j database, please watch my first video. So now let's check. Give me here. Now, as you can see in here, we have nothing. You can check in here, the node is 0 and the relationship is 0. So now let's try to observe this. Now let's check. And yeah, it's done. So now let's check to our Neo4j data. Okay, it's cool. We have the word, the characteristics, the companies, person. If you want to see the whole knowledge graph that we have, we can also use this query, and boom, it's a very beautiful. And here we have Tim Cook, and then Apple's, the universities, the product, the iPhone, Apple Maps, the Project Titan. So yeah, I think it's cool, and that's it from today. So we have learned about how to convert a raw text to a knowledge graph, start from the extracting the entities and relationships, and how to convert these entities and relationships to the Cypher Query, and from the Cypher Query to push it to our Neo4j database.
I hope that this tutorial is useful for you guys. If you have any questions, thoughts, or comments, just let me know in the comment sections below. Bye-bye.